Quadratic equation is given, write them as product of two linear factors. If any cubic equation is given, write them as a product of three different linear factors. When you have a repeated linear factor, you need to write it in the form of A, B, C only, but B or C can be written in the form of x plus 3 whole square. If you take x is equal to 0, it will be in the sum of A, B and C. So instead of taking x is equal to 0, the better way is to equate the coefficients. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to revise the chapter partial fractions. So we have seen various methods of resolving a partial fractions as well as improper fraction to proper and then resolve into partial fraction. Well, for the examination, you have only one 5-mark question from this chapter. So let's see the distribution of marks. So from this chapter, partial fraction, you have section D, that is part D section, you have one 5-mark question. So the total marks from this chapter is itself 5 marks. So that means in examination, you will get one question on 5 marks from the chapter partial fraction. So let us resolve few problems. Resolve into partial fraction. The partial fraction is given as x square, x plus 1, x plus 2, x plus 3. So clearly you should know that always the degree of the denominator should be less than the degree of the denominator. Then only it is proper fraction. Only proper fraction can be resolved into partial fraction. In case improper fractions are given, divide numerator by denominator, express it as a sum of numerical and proper fraction and then resolve proper fractions. So let's start writing this. So we have x square, we have three different linear factors, that is x plus 1, x plus 2, x plus 3. If we doesn't have any linear factors in the denominator, split them as linear factor. For example, if any quadratic equation is given, write them as product of two linear factors. If any cubic equation is given, write them as a product of three different linear factors. So now this can be written as A by x plus 1 plus B by x plus 2 plus C by x plus 3. Now taking LCM and equating the numerator on both sides, we will get the equation as x square is equal to A into x plus 2, x plus 3, B into x plus 1, x plus 3, C into x plus 1, x plus 2. Now since we have three linear factors, we can equate all the linear factors to 0. So first one we have x plus 1. If I equate it as x plus 1 is equal to 0, then we can get x is equal to minus 1. So let me take this as equation 1 and this as equation 2. Now substitute x is equal to 1 in equation 2. Then what happens? Minus 1 whole square is 1. And wherever you put minus 1 here, the term will become 0 for B and C because minus 1 plus 1 becomes 0 here. So the whole term is 0. Here also minus 1 plus 1 is 0. The whole term is 0. So we only get A as minus 1 plus 2, 1. Next, minus 1 plus 3 as 2. So this implies A is equal to 1 divided by 2. Next, put x is equal to minus 2 in equation 2. So minus 2 means minus 2 whole square is 4 here. So you can clearly observe if x plus 2 can be equated to 0. So wherever you have the term x plus 2, the term completely becomes 0. So A and C terms will become 0. So we have only B as minus 2 plus 1, which is minus 1, minus 2 plus 3, which is 1. So minus B is equal to 4. So therefore we'll get B is equal to minus 4. And the last one we will put x is equal to minus 3 in equation 2. So x is equal to minus 3 means we have equated x plus 3 as 0. So here the term containing x plus 3 becomes 0. So we have only C left. So here minus 3 whole square is 9. So we have C into minus 3 plus 1, which is minus 2, minus 3 plus 2, which is minus 1. So therefore, we get C is equal to 9 divided by 2. Now, we have got the value of A, B and C. Substitute it back to the equation 1. So therefore, x square whole divided by x plus 1, x plus 2, x plus 3 is written in the form of sum of simple fractions. Now, A is here 1 by 2. So, we will get this as 1 by 2 into x plus 1. Next, we have B as minus 4. So, it becomes minus 4 divided by x plus 2. And C as 9 by 2. So, it becomes 9 by 2 into x plus 3. So, this is how we have resolved the given rational function. Next, 3x plus 2 divided by x minus 2 x plus 3 whole square. So now when you have a repeated linear factor, you need to write it in the form of a, b, c only, but b or c can be written in the form of x plus 3 whole square. So now this can be written as 3x plus 2 whole divided by x minus 2 x plus 3 whole square. So this can be written as a divided by x minus 2 plus b divided by x plus 3 whole square plus c divided by x plus 3. So whenever repeated linear factors are there, you need to expand it like this. So now again taking LCM and equating the numerator, we will get 3x plus 2 is equal to a into x plus 3 whole square plus b into x minus 2 plus c into x minus 2 x plus 3. So equation 1, equation 2. Now we have two factors here. Let me take x minus 2 is equal to 0. If I take x minus 2 is equal to 0, I'll get x is equal to 2. So put x is equal to 2 in equation 2. Then we get 3 2s are 6. 6 plus 2 as 8. Now x minus 2 is 0 means b and c becomes 0. So we get a is equal to 2 plus 3, which is 5 square. So this is 8 is equal to a into 25. So this implies a is equal to 8 divided by 25. Next, let's take x plus 3 as 0. If I take x plus 3 as 0, then I'll get x is equal to minus 3. So put x is equal to minus 3 in equation 2. Then the term containing x plus 3 will become 0. So we have only left with b. So 3 into minus 3 is minus 9 plus 2 is equal to b into minus 3 minus 2. So we will get here minus 7 is equal to minus 5b. So therefore I can write b as 7 by 5. Now we doesn't have any other term to equate it to 0. So that's why we can either take x is equal to 0 or try the method of equating the coefficients. Now instead of substituting x is equal to 0, I'll just equate the coefficient of x square on both sides. Okay. So equating coefficients of x square on both sides of equation 2. So observe equation 2 here. Do you have any x square on the left hand side? No, we doesn't have any x square term on the left hand side. So therefore its value is 0. On your right hand side, since x plus 3 whole square can give you the term x square and its coefficient will be a. Next, b doesn't have any x square term, but c has x square term because we have x into x becomes x square, which is cx square. So therefore we have a term x square for c. So from this we'll get a plus c is equal to 0. So if I want c, it can be taken as minus a. And we have got the value of a as 8 by 5. So minus 8. And we have got the value of a as 8 by 25. So here minus 8 by 25. Minus 8 by 25. So now substituting the value of a, b, c in 1. Okay. So equation 1 implies 3 x plus 2 divided by x minus 2 x plus 3 whole square is equal to 8 by 25 x minus 2 plus 7 by 5 x plus 3 whole square plus minus 8 by 25 x plus 3. Or you can write this as 8 by 25 x minus 2 plus 7 by 5 x plus 3 whole square minus 8 by 25 into x plus 3. Thus, we have resolved the given partial fraction. Next, 2x square minus 4x plus 1. Again, we can express it in the form of ABC, and here we have a repeated linear factor. So that's why we can write 2x square minus 4x plus 1 divided by x plus 2, x minus 3 whole square as a divided by x plus 2 plus b divided by x minus 3 whole square plus c divided by x minus 3. Now taking the LCM and equating the numerator, we will get 2x square minus 4x plus 1 a into x minus 3 whole square plus b into x plus 2 plus c into x plus 2 x minus 3. So let this be 1, let this be 2. So substituting x plus 2 as 0, we will get x is equal to minus 2. So put x is equal to minus 2 in equation 2. Then here minus 2 whole square is 4. 4 2s are 8. Minus 4 2s are 8 plus 1. The term containing x plus 2 will become 0. So that means b and c becomes 0. So is equal to, put minus 2 here, a into minus 2 minus 3 whole square, which is minus 5 whole square, or we can take it as 25a. Here we'll get 9. So 9 is equal to 25a. So therefore we will get a is equal to 9 by 25. A is equal to 9 divided by 25. Now let's take x minus 3 as 0. So taking x minus 3 as 0, we will get x is equal to 3. So put x is equal to 3 in equation 2. So putting 3 square is 9, 9 2s are 18, minus 4 3s are 12, plus 1. Here the term containing x minus 3 will become 0. So AC becomes 0. We'll get B as 3 plus 2. So 18 minus 12 is 6, 6 plus 1 is 7. 7 is equal to B into 5, or this implies B is equal to 7 by 5. Again, we doesn't have any other term to equate it to 0. We can take x is equal to 0. If you take x is equal to 0, it will be in the sum of a, b and c. So instead of taking x is equal to 0, the better way is to equate the coefficients. Now let me equate coefficients of x square on both sides. Both sides of equation 2. Now on the left hand side, you have 2 as the coefficient for x square. On the right hand side, we have a and c. So a plus c. So if you want c, it is 2 minus a, which is 2 minus, what is a? We have 9 by 25. So on solving this, we will get c is equal to, here 50 minus 9 by 25. So we will get the value as 41 by 25. So let us substitute the value of a, b and c in equation 1. Then equation 1 implies 2x square minus 4x plus 1 whole divided by x plus 2 x minus 3 whole square is equal to a is 9 divided by 25 into x minus 2 plus b is 7 by 5 into x minus 3 whole square plus c is 41 by 25 into x minus 3. So thus we have resolved the given partial fraction. Next, x minus 1, x, x plus 2, x plus 4. So we have three factors, x, x plus 2, x plus 4 here. So we can write this as x minus x, x plus 2, x plus 4 is equal to a by x plus b by x plus 2 plus c by x plus 4, 1. So taking LCM and equating, we'll get x minus 1 as a into x plus 2, x plus 4 plus b into x plus 4 plus c into x plus 2. Take this as equation 2. So initially we can take x is equal to 0. Put x is equal to 0. Then this implies 0 minus 1 is minus 1. Wherever you have x, the whole term becomes 0. B and C becomes 0. So we can take this as 0 plus 2 as 2. 0 plus 4 as 4. So therefore we get a is equal to minus 1 by 8. Next we can take x plus 2 as 0. If you take x plus 2 as 0, we will get x is equal to minus 2. Then it becomes minus 2 minus 1 minus 3. The term containing x plus 2 will become 0. So we have only left with b. So b into minus 2 plus 4 is 2. So we have minus 3 is equal to minus 4b. So this implies b is equal to 3 by 4. Next we can take x is equal to minus 4. So that means we can take x plus 4 as 0. The term containing x plus 4 will become 0. So we have minus 4 minus 1 on the left hand side, and on the right hand side we have c into minus 4. Minus 4 plus 2 is minus 2. So here you will get minus 4 plus 2, which is minus 2. So we have minus 5, 8c. So this implies c is equal to minus 5 by 8. So we have a, b and c here. So substituting this, equation 1 implies x minus 1 whole divided by x into x plus 2, x plus 4 is equal to, a is minus 1 by 8. So we can write it minus 1 by 8x. Next we have b as 3 by 4. So we'll get plus 3 by 4 into x plus 2. Next we have c as minus 5 by 8. So we can write this as minus 5 by 8 into x plus 4. So these are the few questions I have taken, so which you can try to resolve other partial fractions also. Thus you will get one question from this chapter in your examination. We'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.